Hi everyone, my name is Molly Maddox, and my teammates and I are going to go over the disease we have picked out, which is infectious mononucleosis. We will go over a few topics, such as its history, its cause, the signs and symptoms, and a few others to help you have a broader understanding of this disease. So to start this presentation, we are going to look at this disease's history, which has three main dates. The first date, it will be in the 1880s, the second date is the 1920s, and the third, the 1960s. So to start, in the late 1880s, the term infectious mononucleosis was never created. However, in 1885, the Russian pediatrician Nil Filatov reported an infectious process that he liked to call the idiopathic adenitis, which showed symptoms that corresponded to infectious mononucleosis. And in 1889, a German paleontologist and pediatrician, so paleontologist just means in ancient times when they would use spas and bathtubs to help cure diseases, Emil Pfeiffer independently reported similar cases that tended to cluster in families, for which he coined the term glandular fever. So then in 1920, the term infectious mononucleosis was created by Thomas Brunt and Frank Evans in the medical journal called the Bulletin of Johns Hopkins Hospital, which they entitled this the mononuclear leukocytosis in reaction to acute infection, infectious mononucleosis. A lab test for infectious mononucleosis was developed in 1931 by Yale School of Public Health professor John Paul and Walls Bunnell, based on their discovery of heterophile antibodies in the sera of persons with this disease. The Paul Bunnell test, or PBT, was later replaced by the heterophile antibody test. So now we're going to move forward to 1964, when EBV, also known as the Epstein-Barr virus, was discovered using electron microscopy to detect the virus in cultured Burkitt lymphoma cells. So Epstein believed that another lab should repeat his findings. However, British virologists were not interested with working with him. So he sent the cells to Klaus Hummler in Philadelphia, who unfortunately could not work in his laboratory. So he brought the cells to Hennell Laboratory, which was also in Philadelphia, where Epstein's discovery of a new herpes virus was quickly confirmed and additional studies launched to further characterize this virus. Now we're moving on to 1967, when a technologist working in the Hennell Laboratory who lacked antibodies against EBV regularly donated lymphocytes for EBV transmission and transformation experiments. Unfortunately, her cells never survived in culture. So she became ill in 1967, and her physician's clinical impression was rubella versus infectious mononucleosis. Her rubella antibodies were negative, but her heterophile antibody test, which had been established as the laboratory method of choice to diagnose infectious mononucleosis, was positive. Her lymphocytes now grew in culture and were positive for EBV antigens. She also had EBV-specific antibodies, which was the crucial clue that EBV was responsible for a common acute infectious disease. And this will lead us to the cause of infectious mononucleosis in the next slide. Now moving on to the causes of infectious mononucleosis, the main cause of it is EBV, or the Epstein-Barr virus. So what is EBV? The Epstein-Barr virus is one of the 9 known human herpes virus types in the herpes family and is one of the most common viruses in humans. It is different than the herpes simplex virus that causes genital and oral herpes. So the infection with EBV occurs by the oral transfer of saliva and genital secretions. Most people become infected with EBV and gain adaptive immunity. EBV infects B cells of the immune system and epithelial cells. Once EBV's initial lytic infection is brought under control, EBV latency persists in the individual's memory B cells for the rest of their life. Other infections can cause infectious mononucleosis, such as CMV or cytomegalovirus, toxoplasmosis, HIV, rubella, hepatitis A, B, or C, and the adenovirus. It is common among teenagers and young adults, especially college students. At least 1 out of 4 teenagers and young adults who get infected with EBV will develop infectious mononucleosis.
Okay, so first thing I'm going to look at is signs and symptoms. And the symptoms for infectious mono usually show up about 4 to 6 weeks after being infected. And many of the symptoms associated with infectious mono often appear in the body slowly and they don't always happen at once. So a lot of the main symptoms are going to be extreme fatigue, fever, sore throat, head and body aches, swollen lymph nodes in the neck and armpits, and various rashes, and just having your spleen and liver swollen are some of the less common symptoms that you can have as well. And even if you've gotten better for the most part, people will often still feel very fatigued and have like very small traces of symptoms for up to 6 months after the infection is gone. So now we're going to be looking at people at risk. By the age 30, 90% of the people will have antibodies for infectious monos. That means that they were definitely exposed to it in some way by this point in their life. Most people that do contract infectious mono are between the ages of 15 and 24, whereas for adults, it's a much less common thing to see in someone. In the United States, 25 to 50% of children living in lower socioeconomic circumstances have been infected by the age 4. So, yes.
Hey everyone, my name is Jalissa Rios. I have covered the topics of prevention and environmental factors for infectious mononucleosis. So, starting with prevention, infectious mononucleosis is also sometimes referred to as the kissing disease. It can easily be spread through many different ways, but there is multiple ways that it can be prevented. So, firstly, if you know anyone or someone who has mononucleosis, is to try to basically stay clear and avoid these people. You shouldn't be coming around these people at all. Next, this one's pretty obvious. If you have any symptoms, you should not be kissing other people or basically just going out in general. Mononucleosis is also transferable through semen, so protective wear is needed to keeping yourself and others free of disease. And this is just essential for any diseases that are transferable through sexual intercourse. Next, washing your hands regularly is necessary to living a healthy life in general. Just washing your hands can help you stay clear of many diseases, including mononucleosis. Most importantly, it is important to not share any cups, silverware, makeup, or any hygiene products. So basically anywhere around your mouth, your face, because this can easily lead to getting the disease. Just try to stay clear of using any of your roommates' silverware and stuff like that. Next, this point is more directed towards any parent or caretakers, but after any playtime, parents should wipe down all toys that have been in their children's mouths. This is very essential to keeping your kids clean as well as other people and helping people not spread that disease as much. And lastly, having good healthcare in general can be the main way to avoid any diseases. Just having a good hygiene system, a stomach care, having taken care of yourself is a good way to not get infectious mononucleosis. Next, for environmental factors, infectious mononucleosis is primarily caused by the Epstein-Barr virus. Some of the main environmental factors surrounding the disease include people coming into close contact with others, Everyone should keep their distance when talking to others, like a safe distance, just so we're not spitting or breathing on other people when talking to others. Being in crowded environments like college campuses like Texas State and any dorms is more at risk than other places. Obviously, I would just say try keeping out of crowded environments as much as you can. People who are younger are generally at the most at risk because of our social lives compared to older or very younger people. During this age, we go out more, so we're more at risk for the disease. And lastly, winter seasons are when the virus spread more easily.
Hi everyone, this is Molly again. Now we're going to go over the public health efforts for infectious mononucleosis. So the National Institute of Allergy and Infectious Diseases has launched an early stage clinical trial to evaluate a preventative vaccine for the Epstein-Barr virus. So leading this trial is Principal Investigator Jessica Dirk-Schock. The study will evaluate the safety and immune response of an investigational EBV vaccine. The experimental vaccine was developed by the Laboratory of Infectious Diseases in collaboration with the National Institute of Allergy and Infectious Diseases Vaccine Research Center. The vaccine works by targeting EBV glycoprotein GP350, which is found on the surface of the virus and virus-infected cells. EBV GP350 is also the primary target for neutralizing antibodies found in the blood of people naturally infected with EBV. Ferritin, a natural iron storage protein found in cells of all living species, is considered a promising vaccine platform because it can display proteins from the targeted virus in a dense array on its surface. The adjuvant is intended to enhance the immune response induced by the investigational vaccine. This study will enroll 40 healthy volunteer adults ages 18 to 29 years old, half of whom have evidence of prior EBV infection, and half of whom do not have evidence of prior EBV infection. Participants will be given a series of 350 microgram injections of the experimental vaccine in the upper arm muscle, followed by 30 to 60 minutes of observation after each dose. The second and third doses will be administered 30 days and 180 days after the initial dose, with a follow-up visits between each vaccination and phone calls between visits. Participation is expected to be required for 18 to 30 months, and the trial is expected to last 4 years. And hopefully this will reduce the transfer and severity of the disease.
Hi, my name is Kendall, and I'll be talking to you about treatment, evidence, and non-evidence-based for mononucleosis. Because mono is caused by a virus, medications such as penicillin will not assist unless the child has a bacterial illness. Mono symptoms normally resolve themselves within a few weeks. The best therapy is to get plenty of rest, drink enough fluids, and eat healthily. You should not use penicillin, antibiotics like ampicillin or amoxicillin if you have infections like mononucleosis. A healthcare physician may propose therapy of certain organ systems affected by infectious mononucleosis based on how extreme the symptoms are. Hi, my name is Kendall, and I'll be talking about the treatment, evidence, and non evidence based for mononucleosis. Because mono is caused by a virus, medications such as penicillin will not assist unless the child also has a bacterial illness. Mono symptoms normally resolve themselves within a few weeks, so the best therapy is to get plenty of rest, drink enough fluids, and eat healthily. You should not use penicillin antibiotics like ampicillin or amoxicillin if you have infectious mononucleosis. The risk of rash with some medications like amoxicillin and other antibiotics, including those made from penicillin aren't recommended for people with mononucleosis. In fact, some people with mononucleosis who take one of these drugs may develop a rash. These rashes don't necessarily mean that they're allergic, but to the antibiotic, but however, if needed, other antibiotics that are less likely to cause a rash are available to treat infections that may go along with mononucleosis.
All right, this is Molly again. And lastly, we have our references. And this concludes our presentation. I hope you all enjoyed that and learned something new today. Thank you.